In this video, we want to find limits that are in the form of infinity minus infinity. The first question is limit of 1 over x minus 1 over e to the x minus 1 as x approaches 0. We want to find limit of this expression when x approaches 0. First, note that when x approaches 0, 1 over x goes to infinity, approaches infinity. Why? Because numerator is a number, is a 1, and the denominator approaches 0. And we know that when the denominator approaches 0, but the numerator is non-zero, that fraction approaches infinity. Any number, in general, any number over something that approaches 0 goes to infinity. So 1 over x when x approaches 0 goes to infinity. 1 over e to the x minus 1 as x approaches 0 also goes to infinity. So this limit is in the form of infinity minus infinity. Let me explain you why this goes to infinity. Numerator is 1. If you direct substitute 0 here, then denominator approaches 0. E to the 0 is 1, 1 minus 1 is 0. So again we have a number, a non-zero number over something that approaches 0, so this is also infinity. So this limit is infinity minus infinity. And infinity minus infinity is an indeterminate form. So you cannot say that infinity minus infinity is 0. No, that's not true. Infinity is not a number. So you cannot subtract infinity from infinity and say simply it's 0. So let's see what is this limit. For finding this type of limits, first we do usually common denominator if they are in fraction form, which here we have two fractions, so simply first we have to do a common denominator between these two fractions. The common denominator is x times e to the x minus 1, and the numerator would be e to the x minus 1 minus x. This goes here, and this goes here, and also consider this negative in the middle. Now we have a limit that is in the fraction form, and so we can use L'Hopital's rule to find this limit. So we apply L'Hopital's rule for finding this limit. If you remember the L'Hopital's rule for finding limits, it's a powerful rule for finding limits that are in the fraction form. And the limit that here we have is in the fraction form. We have something in numerator, something in denominator, and based on the L'Hopital's rule, simply we have to differentiate numerator and denominator separately. Derivative of e to the x is e to the x. Derivative of 1 is 0, and derivative of minus x is negative 1. So the derivative of numerator is e to the x minus 1. But in the denominator, attention, you need to apply product rule, because in the denominator we have x times by e to the x minus 1. So for finding derivative of denominator, you need product rule. Let me remind you briefly the product rule. If you have u times v, derivative of u times v is u prime times v plus uv prime. So for finding derivative of x times e to the x minus 1, first we take derivative of only x. And derivative of x is 1, so we have 1 times e to the x minus 1. Then we have to write the first function, which is x. And we have to take derivative of the bracket. Derivative of e to the x is e to the x, and derivative of 1 is nothing, is 0. So derivative of the bracket is only e to the x. Now we have this fraction. Basically, after L'Hopital's rule, we do direct substitution to see if we can find the limit by direct substitution or not. But if you simply plug in 0 in numerator, you can simply see that e to the 0 is 1 minus 1 is 0, so the numerator is 0. And if you substitute 0 in the denominator is also 0. Simply we can check this. Simply you can check this by yourself. Now that we have again a 0 over 0, we can apply L'Hopital's rule again to find the limit. Derivative of numerator is e to the x only, because derivative of e to the x is e to the x and derivative of negative 1 is 0. Here, attention, 1 times e to the x minus 1 is basically only e to the x minus 1, because 1 times every expression is that expression. So in the denominator we have e to the x minus 1 plus x e to the x. Derivative of e to the x is e to the x. Derivative of minus 1 is 0. For finding derivative of this term, you need to use again the product rule, because you have x times e to the x. Derivative of x is 1 times e to the x is e to the x plus write x and take derivative of e to the x, and derivative of e to the x is itself. Now plug in 0 again to see if we can find the limit or not by direct substitution. If we plug in 0, e to the 0 is 1. This is also 1 and this is 1. But here, because we have x here, 0 times e to the 0 is 0. So the denominator is 1 plus 1 plus 0. So the denominator is 2. So the limit is 1 over 2. Let me show you another example. Now we want to find limit of cosecant x minus cotangent x as x approaches 0 from the right. For finding this limit, the first thing that we are going to do is to get rid of cosecant and cotangent, because usually we prefer to rewrite these trig functions, these trig ratios, in terms of the other trig functions that we are more familiar with. For example, we know that the definition of cosecant of x is 1 over sine x, and also we know that cotangent of x is cosine x over sine x. This is the first thing that we have to do to find this limit. And attention, this limit is infinity over infinity, infinity minus infinity. How we know this? Simply, if you plug in 0 here, sine of 0 is 0. Again, we have a non-zero number over 0 and it goes to infinity. And the next fraction, cosine 0 is 1, the sine of 0 is 0, 1 over 0 goes to infinity. So this limit is infinity minus infinity. For finding this limit, similar to the previous question, we are going to do common denominator. And actually, here the denominators are the same. We don't need to do really a common denominator. The denominators are the same, so simply we subtract the numerators. We put 1 sine x in the denominator and we subtract 1 cosine x from 1. So we have 1 minus cosine x over sine x. Now we face a limit that is in the fraction form, and it is basically 0 over 0. So for finding this limit, we are going to use L'Hopital's rule. Derivative of sine x is cosine x. Derivative of numerator, derivative of 1 is 0. Minus derivative of cosine x, negative sine. If you simplify this, it's sine x over cosine x as x approaches 0. Now if you substitute 0, you have sine 0 over cosine 0. Sine of 0 is 1, cosine of 0 is 1, and it equals 0. So the limit of cosecant x minus cotangent x as x approaches 0 is 0. Now look at this example. We want to find limit of 1 over x minus 1 minus 1 over ln of x as x approaches 1. This limit is again infinity minus infinity. You can check this by direct substitution. And for finding this limit, we are going to do a common denominator between the two fractions. We want to make it one single fraction, so we do common denominator. Then in numerator we have ln of x minus x minus 1. If you apply this minus in this bracket, then it becomes negative x plus 1. So let's do it here. So we have minus x plus 1 as x approaches 1. If you do substitution, if you plug in 1 in numerator and denominator, simply you can see that this limit is 0 over 0. And we know that for finding these type of limits that are 0 over 0, one powerful tool for finding these type of limits is L'Hopital's rule. So we apply L'Hopital's rule. What was L'Hopital's rule again? Take derivative of numerator and denominator separately. Derivative of ln of x is 1 over x. Derivative of minus x is minus 1. Now for finding derivative of denominator, you need to use product rule because you have x minus 1 times ln of x. Based on the product rule, we take derivative of the first function, the first term, which is x minus 1. Derivative of x minus 1 is 1. So 1 times ln of x, or simply ln of x, plus write x minus 1 and take derivative of ln of x, which is 1 over x. Now if we plug in 1 for x to see if we can find the limit by direct substitution, we can simply see that 1 over 1 in numerator minus 1 is 0, and also the denominator is also 0. Because the limit is 0 over 0 again, we apply L'Hopital's rule again. By applying L'Hopital rule, we have to find derivative of numerator and derivative of denominator again. Derivative of 1 over x is negative 1 over x to the 2. And derivative of minus 1 is 0. Let me explain you here why derivative of 1 over x, why derivative of this expression is negative 1 over x to the 2. There is two ways that you can find derivative of 1 over x. One way is to write 1 over x in the form of x to the negative 1 and use the power rule. Then derivative of this would be negative 1 x to the negative 2. And if you rewrite x to the negative 2 in the fraction form, negative 1 times x to the negative 2 is basically negative 1 over x to the 2. The other way that you can find derivative of 1 over x is to use quotient rule. And if you use quotient rule, derivative of numerator is 0 times by x is 0, all of this is 0, minus write the numerator which is 1 times by derivative of x which is 1, so 1 all over x2. This is negative 1 over x to the 2. So derivative of 1 over x is simply negative 1 over x to the 2. Now we have to find the derivative of the denominator. The derivative of ln of x is 1 over x. For finding the derivative of this, you can first multiply 1 over x in the bracket and then take the derivative, or you can take the derivative of this right away, but you need to use the product rule. Let's use the product rule now. The derivative of the bracket x minus 1 is just 1, because the derivative of x is 1, the derivative of negative 1 is 0, so the derivative of the bracket is only 1. Times by 1 over x plus write down x minus 1 and take derivative of negative 1 over x. What is derivative of 1 over x? Negative 1 over x to the 2. Now, here if we plug in 1 in numerator and denominator, in the numerator if we plug in 1, it would be only -1, because -1 over 1 would be -1. If we plug in 1 in the denominator, this fraction is 1, this is also 1, and this would be 0, because 1 minus 1 is 0. Denominator is 2, so this limit equals -1 over 2. Before I show you the next example, let me tell you something about here. If you want to make finding the derivative of numerator and denominator simpler, maybe it's not bad idea that here multiply the numerator and denominator of this fraction by x to get rid of the fractions and then apply L'Hopital's rule. But I prefer this method, so I applied L'Hopital's rule right away without simplifying that expression. Now look at this example. We want to find limit of x minus ln of x as x approaches infinity. For finding this limit, the problem that we have is that we don't have fractions, and so we cannot combine these two terms together and make it like a single fraction and then apply L'Hopital's rule. We need fraction, then we can apply L'Hopital's rule. So we have to find a way to make this something in a fraction form. But how we can do that? If you factor x from these two terms, then we have limit of x times 1 minus ln of x over x. Now by factoring x, we have fraction ln of x over x. Now attention to this. We want to find limit of ln of x, only limit of this part of the expression, when x approaches infinity. 1 is 1, we don't need to find that. Limit of 1 is 1. We want to know what is limit of ln of x over x as x approaches infinity. So, attention to here. What is limit of ln of x over x? Why I choose this part of the limit? Because this is in the fraction form, and we can use L'Hopital's rule for finding such limits. And also attention that this limit is in the form of infinity over infinity, because the denominator is x and x approaches infinity. And when x approaches infinity, ln of infinity is also infinity. When x approaches infinity, ln of x goes to infinity. If you remember, graph of ln of x, let me graph the function ln of x for you here. This is the graph of y equals ln of x. As you can see, when x approaches infinity, when we go far to the right, the y value of the function also goes infinity. So this limit is in the form of infinity over infinity, and we can use L'Hopital's rule when we have infinity over infinity. If we use L'Hopital's rule, derivative of ln of x is 1 over x, derivative of x is 1, and x goes to infinity. When x approaches infinity, 1 over infinity, 1 over x goes to 0. Limit of any number, doesn't matter it's 1 or any other number, over x, when x approaches infinity, is 0. We know this rule. So this limit equals 0. Now that we have found limit of ln of x over x as x approaches infinity is 0, so the limit of the bracket, limit of all of these brackets, when x approaches infinity is 1 minus 0. ln of x over x is 0, 1 minus 0 is 1. But x goes to infinity, so we have x times by 1, and x times by 1 is x, and when x approaches infinity, so the limit equals infinity. So this limit equals infinity. So limit of x minus ln of x when x approaches infinity is infinity. And this makes sense, and we could probably predict that this limit is infinity. How? Because we know that when x approaches infinity, ln of x grows is slower than x. If you compare graph of ln of x, which is something like this, and x, if you compare these two functions, simply we can see that when x approaches infinity, when we go far to the right, ln of x grows slower than x itself. The distance, the difference between them, x minus ln of x, this is this distance. When we go far to the right, this distance between them grows very fast, and so the limit is infinity. I hope by watching this video you have learned how to find limits that are in the form of infinity minus infinity by L'Hopital's rule. If you like this video, please subscribe in my channel and see you in the next videos.